Hi guys, you welcome back to my channel. Today we want to take a look at chemistry revision class. For those students out there who are preparing for Jamb, and to those students who just take their examination today, you can also go back and watch this video. And if you are writing your exam tomorrow, this video is for you. Or if you are writing your exam next week, this video is for you. I'll be taking some topics relating to some questions here, which will also serve as a guide for your Jamb examination. Look at this now. It said the reaction between an alkana and an alkanoic acid will produce what? Produce what? A. Alkana, B. Alkanon, C. Alkanoate, D. Alkanoic acid. Out of these four options, alkanoic is not there because it is being stated clearly in the question that we have to look at the reaction between an alkano and an alkanoic acid. We produce what? So let's take a look at this now. You can say you have alkano plus alkanoic acid. So we have a reversible reaction, esters plus water. Or we can also call these alkanoates. Like this now, our answer is C. But how can we prove this? It's very what? Very simple. One thing you should note about this reaction between an alkano and an alkanoic acid is that you have to look at the first step mechanism, which is what you have on the board. So if I have RuCOH, this is a functional group of alkano, which is, we can also call it alcohol. Or to those language outside, we can use what? Ogogoro. But here in chemistry we call it what? Alkanoic. And for alkanoic acid, we can also call it carboxylic acid. Just the way I said, esters is the same thing as what? Alkanoids. Is that clear now? So now, plus RuCOOH. So now, this reversible reaction, we want to show it now. So before we can show that reversible reaction, we have two forms of reaction here. The first one is esterification reaction, while the second one is hydrolysis, which I'll be showing you guys here now. So for this, I have RuOH plus, for this now, I say R double bond here, OH. So now, this forward reaction is esterification. And here, the backward reaction, we have hydrolysis. Is that clear now? So guys, so looking at this RuOH, this Ru serve as alky, but here we are having what a class? OH reacting with this H here. So when it comes together, we have this kind of Ru here. So this Ru here is going to replace the H. Then that means we're having two R. We're having what? R prime. So with that, like I said, I have repeat what you have. So you can say R double bond oxygen. We have O. Then the R we pick from the what? OH here. So we have R here prime plus OH plus hydrogen here. I'm going to have what a class? Water. So the reaction between an alkano and an alkanoic acid will produce alkanoate, which is this. So how do we have esterification reaction? Because for every OH and carboxylic acid to have esters and water, that will have what? Esterification reaction. Why hydrolysis is like this? Taking your alkanoate to this place, reacting with water, because not one thing as Jamb students out there, you can either have any particular question. For example now, the reaction between sucrose plus water in the presence of dilute HCl will yield fructose. Any reaction you come across in your Jamb past question practice that deals with a particular stuff with water, it means that kind of reaction undergo what we call hydrolysis. So the reverse reaction here is what, class? Hydrolysis. Is that clear now? So let's take a look at another question. So number 2, we ask calculate the oxidation number of sulfur in the following. A, we have SO2. B, we have SO3. C, we have SO4, 2 minus, and D, we have H2, SO4. So class, looking at what you have on the board now, don't forget the rules that I always tell you guys that whatsoever any question you come across in your Jamb examination, you should be able to tell the topic. So looking at what you have on the board now, this particular question fall under oxidation and reduction. So guys, I said calculate the oxidation number of sulfur in the following. So guys, I'm going to solve for oxidation number of each of the following. Mind you, I'm not picking outside here, but I'm going to show you guys how to calculate the oxidation number of each of those options there. So for this sulfur, and what? Sulfur. And among the rules, when it's come to oxidation number, if you are given a particular number that does not have any charge, that means that particular compound is equal to 0. But if you are given a compound that has a charge, that means that compound is equal to what? That particular charge. For example, now I have SO2. This compound will be equal to what? 2. And mind you, what is the oxidation number of sulfur? Sulfur belongs to group 6 elements, was that the oxidation number of sulfur is -2. But yeah, so guys, what is the oxidation number of oxygen? Oxygen and sulfur, they belong to the same group, with that their oxidation number is what, class? -2. So here I can say that I have S plus -2. What do you have here? Times 2 is equal to what? 0. Minus times plus, say we have what? Minus 2 times 2, we have what, class? 4 equal what? 0. So if we have to take this to the other side, say S is equal to what? Plus 4 for this now. So the oxidation number here for SO2 is what? Plus 4. So if we are to name this compound, we can say sulfur dioxo, or we can say sulfur 2 oxide, or sulfur 4 oxide. So guys, the second one, this one is A, and this I have SO3. This compound is equal to what? 0. So it said S plus -2 times 3 is equal to 0. Plus times minus, said what? -2 times 3, we have 6 is equal to 0. S is equal to what? Plus 6. So the oxidation number of sulfur here is plus 6. Is that clear now? So we can say trioxosulfate 6 acid. Again, trioxosulfate what? 6 acid. So let's take a look at this C. We have SO4, so minus. So this compound will be equal to what, class? -2, according to the rule. So we said S plus -2 times 4, we have what? -2. So class, -2 plus times minus, we have what? -2 times 4, we have what? 8 is equal to what? -2. So with that, I said -2 plus 8, S is equal to what? Plus 6. So with that, I said tetra. This form is what? Tetra. So I said tetraoxo sulfate 6 acid. Is that clear now? So let's take a look at the last one, which is H2SO4. So mind you, this compound will also be what? Equal to 0 without any charge. So guys, the oxidation number of hydrogen is what? Plus 1. Okay, said plus 1 multiplied by 2 plus S plus minus 2 times 4 is equal to what? 0. So 1 times 2 we have what? 2 plus S plus times minus 2 times 4 8 is equal to what? 0. So you collect like Tim said, S plus 2 minus 8 we have what? 0. So we can say S minus 6 is equal to 0. S is equal to what, class? Plus 6. So we can say hydrogen tetraoxosulfate 6 acid. So that is how to calculate for oxidation number. Is that clear now? So let's take a look at another question. Mind you, as you are streaming, do it to screenshot anything you think you can easily use after the class. So the third question states which of the following equilibrium is or are unaffected by a pressure change. A, we have 2 sodium chloride, 2 mole of sodium plus chlorine gas. B, I have hydrogen gas plus iodine gas, a reversible reaction, 2 mole of hydrogen iodide. C, D, we have 2 mole of nitrogen oxide, so looking at the question on the board, this question is under chemical equilibrium, and for it to answer the kind of question, it is stated that unaffected by a pressure change. One thing you should note about equilibrium is that if you are given any equation and the change in H, which is enthalpy, is positive, there is increase in temperature. And if the change in H, which is also enthalpy, equals to negative, there is decrease in temperature. That is according to the Taylor's principle. So with this now, for every pressure, for example, now I have A and I have B plus C. Here we have 1 mole and here we also have what? 2 mole. So according to the Taylor's principle, under effect of pressure, are you with me now? It states that there is increase at either side of the equation with smaller volume or mole, and there is decrease as the what? Higher volume or mole. So guys, looking at what we have, 1 mole here. So guys, there is increase here, which is going to what? Shift the equilibrium to the left, and there is decrease here, which is going to shift the equilibrium to the right. So now, according to what we have on the board, state which of the following equilibrium is or are unaffected by a pressure change. So guys, when we look at this now, we have 2 mole here, 2 moles. I also have what here? 3 moles here, or we can also call it what? Volume. So guys, there is effect of pressure here because there is increase at the left hand side of the equation. So let's take a look at B. We have 1 mole here, 1 mole here, so we have what, 2 moles. We also have what here, 2 moles. So guys, there is not, it is unaffected by a pressure change. So I'm coming back to this B. So let's take a look at C and D. We have 2 moles here. We have 3 moles here. There is effect of pressure here because there is increase at the left hand side and also there is decrease at the right hand side. So the last one, we have 2 moles here and here we have 1 mole. So guys, there is increase at the right hand side of this equation. There is also what, decrease at the left hand side of this equation. So let's go back to that B before we can pick our answer. We have 2 moles here. We also have what here, guys? 2 moles here. So meaning that for A, there is effect of pressure here. For C, there is effect of pressure here. For D, there is effect of pressure here. Why? Because we can easily deduce where we can find our increase and decrease of the pressure. But B, we have equal moles from both the left and the right hand side. So there is what? State which of the following equilibrium is or unaffected by a pressure change. So our answer is B. So let's take a look at another question on this, which I think will help you to boost your examination confidence. So we have this, an isotope with an atomic number of 15 and a mass number of 31 contains, so there's no options here, so because I'm here to explain how you can easily have your answer when it comes to isotope. And what do you understand by isotope? This is a phenomenon of 2 or more compounds having the same molecular formula but different molecular structure. We can put it as having the same atomic number but different atomic mass. So now guys, I have X, I have A here, and I have what, Z here. So this is the atomic mass, or we call it mass number, while this Z is our atomic number. So from the equation we have the atomic number to be 15 and a mass number of 31 contains. So guys, the element with atomic number 15 in the first 20 element is phosphorus. So this phosphorus, we have 15 here, then we also have what, 31 as the mass number. So now we have to look for the proton, neutron and electron. So the first one is this proton, this is electron, and here we have what, neutron. So for every neutron, the formula for neutron is that for every neutron we said we have A minus Z, meaning that P, which is a proton, is equal to electron. So with that now, my proton is what? The same thing as atomic number. My electron is the same thing as what? Atomic number, because I said P is equal to what? E. So for you to have your neutron, which is, so that will be 31 minus 15. So our neutron here is what, class? 16. So mind you, if you have like elements calcium with 2 positive, so here we have 40 and we have 20. So the proton here is 20, the electron here is what class? 20. What is a neutron? Don't forget we said we have A minus Z. So now something is what? We have a positive to here to plus. So it means that this calcium is donating 2 electron. With that now we can say we have 40 minus 20. We have what? 20 minus the 2 electron. We have what class? We have 18 neutron. Is that clear now? So guys, I will take the last question under radioactivity. So guys, when we talk about isotope, you need to understand the concept that it deals with having the same atomic number but different atomic mass or mass number. So this is how you are going to solve any question relating to how you can easily calculate for proton, electron, and what guys? Neutron. So let's take the last one. We have this. So say that what is the value of X in the nuclear reaction above? So guys, looking at what you have on the board, we have radon with atomic number 88 and mass number 226, and here we are asked to look for the alpha particle. Note one thing, for every alpha emission or alpha particle we have helium with 4, and here we have what? 2. So meaning that we are going to replace what you have here with this. With that, write the equation back. I said RA, we have 88 226. So we have RN. So guys, when it comes to alpha particle, what you have here is the atomic now. We are going to subtract this 88 from this atomic number of the helium, because this helium represents our alpha particle. So we can say 88 minus 2, we have 86, and we have 226, and here we have what? 4. You can say 226 minus 4, we have what? 222. So guys, when it comes to alpha or radioactivity, this is how you are going to what? Apply, because Jamb will not tell you that your helium under the alpha emission of particles is this. So guys, don't forget to subscribe to my channel, like, comment, and share.